Hey everybody, it's Mr. Millington here. This video is all about finding the surface area of cones. So let's go ahead and get started. Um, this is a cone. I drew a quick picture of a cone. Y'all have seen cones before. Um, they there's two real important distinctions here though between the height and the slant height. Just like when we were talking about pyramids, when we talk about the height of the cone, we're talking about this right here. That's like inside the cone. That's from, like what you might consider the top of the cone, straight down to the middle of the base of the cone. So, or perpendicular, I would say, to the base of the cone. So that's the height. The slant height is the height along the lateral edge of the cone. And the slant height, this is what's really important for us when we're finding surface area. The height sometimes might help us find the slant height. The height is really important when we're finding volume. But for surface area, the slant height is what we're looking for. So keep that in mind. Okay, so cones. You've seen cones before in ice cream cones. Think about what happens if you've ever taken that wrapper off of a cone like that and unraveled it. If you've done that, you've gotten a shape that looks like this. It looks like a big triangle with a kind of a curved edge on the bottom. So the reason we point that out is because the way that you're going to find the area of a cone is identical to the way that you find the area of a triangle. So we'll show you how that works. So we're going to want to keep that in mind. Finding the lateral area on a cone is just like finding the area of a triangle. So find the total surface area of the cone below. So go ahead, take a second and sketch out this diagram and then do an RDCA. Remember, anytime there's a circle, you want to do an RDCA. So go ahead and do that, pause it, and then unpause it once you've sketched this out and done your RDCA. All right, RDCA. Welcome back. Check out my RDCA. They gave us the diameter in this case. The diameter was 28. That means your radius is half of that, which is 14. The circumference would be 28 pi. And then, the area of the circle would be 14 squared pi. So 14 squared is 196. So our area is 196 pi. All right, so there's going to be two different shapes that you get when you unravel a cone like this. One is that triangle shape I was talking about with the ice cream cone, and then the other one is the shape that's on the bottom here, which is a circle, right? So I'm going to draw both of those out. So I'm going to draw the circle, and then I'm going to draw my lateral triangle looking thing. Okay, that's what's up here. This is the lateral edge of the cone. It's all the stuff around like the sides, and that stuff ends up looking like a triangle when you unfold it. Okay, so the area of the circle, we already know from our RDCA that it is 196 pi. Boom, there it is. So 196 pi is our area of the circle part. Now the lateral part, remember when I said it's just like a triangle? It is just like a triangle. You're going to do, so remember area of a triangle is base times height. Base times height divided by 2. So for this lateral piece of the cone, the base is the bottom part here. And if you think about it, that would just wrap around the whole circle on the base. So the lateral part down here, the base of that is the circumference. All right, so it's always whatever the circumference is. So in this case, it's 28 pi. Then the height of this, now imagine again, you unraveled that ice cream cone. The height of this triangle looking thing that you would get, that would actually be the slant height. Slant height. So in this case, our slant height, you can see from the picture, is 50. All right, so just like in a triangle, how you want to do base times height divided by 2, with the lateral area of a cone, you want to do the circumference times the slant height. divided by 2. It's the same idea. I wrote SH there. I don't really love that. I'm going to use what textbooks and the internet use, which is like a lowercase l. That's kind of like in cursive. So that little L means slant height. And you'll see a formula online as well, but Ms. Rose and I tend to avoid using that formula because if you just think of this like a triangle, you don't need to memorize a new formula. It's just base times height divided by 2. So in this case, circumference times slant height divided by 2. So let's do that calculation real quick. Circumference is 28 pi, slant height is 50, and then divided by 2. So when I do all of that, I end up getting 700 pi. 700 pi. So the area of the circle was 196 pi, and then the area of the lateral part was 700 pi. So then you add those up for your total surface area. Total surface area, 700 pi plus 196 pi, you're going to get 896 pi. And this was meters squared. All right, so take a second, make sure you've got that all written down. Think about the steps we took. Circle's easy, you know how to do that. And then the lateral part is just like a triangle. So let's do one more example. What I want you to do is write down your RDCA for this one after you copy it down. And then before you get started finding the total surface area, think about the fact that you need the slant height. That's my big hint for you. You need to find the slant height first. So go ahead and try that. See if you can answer this one. And then when you're ready to check your work, unpause me. All right, hopefully you've tried it and now you're ready to watch my work. I don't know what's going on with my pen in this video. It's everywhere it wants to do weird things. Let's just write, pen, write. Okay, there we go, RDCA. So my radius is 3, diameter would be 6, circumference would be 6 pi, area would be 9 pi. All right, hopefully you also found the slant height. Hopefully you looked at this and said, this is a right triangle. This is my slant height right here. And so that's the hypotenuse of the right triangle. So it would be 3 squared plus 4 squared equals the slant height squared. So 9 plus 16 equals slant height squared, 25. And then you square root both sides and you would get 5 equals the slant height. Or if you know your triples, this is a 3, 4, 5. You could have saved all that work. In any case, our slant height is 5. We've got our different parts that we can break up here. So I've got my circle, which we know has an area of 9 pi. And then I've got my unfolded triangle piece with the curved edge for the lateral area. Okay, so remember we want to use the circumference is the base of that triangle. The height of this triangle is the slant height, which we found was 5. All right, so the area, just like a triangle, base times height divided by 2. Base is 6 pi, slant height is 5 divided by 2. So that's 30 pi divided by 2. So 15 pi would be that area. So I've got 9 pi from the circle plus 15 pi from the lateral part of the cone. So my total surface area, 9 pi plus 15 pi would be 24 pi. Did we have any units on this one? We didn't have any units given to us, so we're just going to say units squared. All right, thanks for watching. I think you'll all agree that cones are the most fun shape that there is until the next one that we learn. Bye!